Welcome to this video on the completing the square and vertex form. I'm going to do this video in two parts. The first part is going to be on this completing the square, and then the second video is going to be on vertex form of a parabola. So the first part of this video has got some equations. We're going to solve them by using the square root property and round to the nearest hundredth if necessary. These are already set up to be perfect square trinomials, and we'll talk about in a minute when it's not set up that way, what you do. So let's just remember that if you're solving an equation of the form x squared equals some number, I'll call it a here. Okay, what we're going to want to do, obviously, is to square root both sides in order to solve that equation. So I'm going to square root the left side and square root the right side. Now in class, we discussed that the square root of x squared has to be absolute value of x. The reason for that is if you think about putting a number that like 2. Okay, so for instance, if we take 2 and we square it, we get 4. Then we take the square root of that 4, we get 2. If we take negative 2 and square it, we get 4. We square root that, we get 2. So whether we're working with a positive or a negative number going in for x, it's going to turn positive in the middle, in the end, which is why we have to say absolute value of x. Whatever x is, once we square it and then we square root, we're going to get a positive value. So x is going to equal the square root of a, which means if it's an absolute value, it could be positive or negative. That's the point of using the absolute value. So x is plus or minus square root of a. So basically, when you have to square root both sides of an equation, you're going to have to take the absolute value, you're going to have to make it plus or minus. Now, I'm okay if you skip this step in your algebraic directions and go straight from doing the square root on both sides to saying plus or minus the number on the right, which is probably what you were taught in Algebra 1 when you did it. Okay, so this first example, we're going to use the square root property, which means we need to write the left side as something squared. X squared minus 8x plus 16 factors into x minus 4 times x minus 4. Or we could write that as x minus 4 squared equals 25. So now we're going to square root on both sides. Square root the left side, square root the right side. And we will say that x minus 4 equals, I'm going to skip over this absolute value step over here in my algebraic work, plus or minus 5. I have to add the 4 over. So it's 4 plus or minus 5, which means x equals 9 if we do 4 plus 5, or it equals negative 1 if we do 4 minus 5. Right, here's another similar one that factors into the same factor twice as we did when we did our factoring lesson previously. If the square root of the first term and the first term is squared, times the square root of the last term when the first term is squared, if you take those and multiply them and then double it, then that means it must be a perfect square trinomial. So this factors into 2x minus 5 times 2x minus 5, or 2x minus 5 squared. So now I do my square root property on both sides. And I can see that I get the square root of 2x minus 5 squared, which is 2x minus 5, equals plus or minus the square root of 32. 32 is 16 times 5, so it's going to be 4 root 5, plus or minus. Okay, so then I'm going to need to add my 5 over to the other side, and then divide everything by 2. So x equals 5 plus or minus 4 root 5 over 2. Of course, you could check this on Desmos by graphing the parabola and seeing that those were the x-intercepts. You should also be able to give the decimal approximation answers. So if I do 5 plus 4 root 5 and then divide by 2, I get approximately 6.97. And then afterwards, it looks like it's a 2. And then if I do 5 minus 4 root 5 and then divide by 2, I get approximately negative 1.9. 0.972. Keep in mind those are x-intercepts, okay, because we are solving for a parabola. Okay, so now let's talk about what happens when they don't give us something like they did up here where it does factor into a perfect square. So we will complete the square to force it to be a perfect square, and this is the process that you will follow to do that. The first thing we will do is we will substitute 0 for the y because we want to remember when we're doing this, we're finding the x-intercepts. And wherever the x-intercepts are, the y is 0. So we're going to remember our two answers have a y-coordinate of 0, and we are going to get the x-coordinates. And then we're going to move the c term to the right. See, I like to write 2x squared plus 8x minus 1 equals 0. I like to always flip it around and have my quadratic on the left. I'm going to move the c term to the right now. 2x squared plus 8x equals 1. Then the next step is if you have a coefficient in front of the x squared, because we know a general trinomial in standard form has a as the first value. If it's not 1, we're going to want to factor that out to make our work easier. So I'm going to take out a 2 out of there, not the 2x, just the 2. I still want it to be a quadratic expression. So I haven't really changed the equation. I'm just writing it in a different format. It equals the same thing. All right, now I need to do my completing the square part like we did in geometry last year. We did one of those as a warm-up today. So we are going to add b over 2 squared. It's really a times that, but our a is out here to the left. 4 over 2 squared to this polynomial to complete the square. So 4 over 2 is 2. I squared that, I get 4. So I've really not just added 4 to the left side because there's a 2 outside parentheses. I've really added 2 times 4. So I've technically added 8 to the left side. So I need to add 8 to the right side. So I've taken care of that. My square is now a perfect square. Okay, next I'm going to factor the left side. It's really handy for you to write the b over 2 in parentheses before it is squared, because whatever this number in parentheses is what goes in the parentheses here. 4 over 2 is 2. So that x squared plus 4x plus 4 right here factors into x plus 2 times x plus 2. And this is 9. Then next and finally, we are going to solve for x like we did a minute ago using our square root property. So that means I'm going to divide both sides by 2. So I have x plus 2 squared equals 9 halves. Then I have to square root both sides, which means on this side, I'm going to square root both the numerator and the denominator. So I have x plus 2 equals plus or minus, the square root of 9 is 3. And then on the bottom, I have root 2. So I'm going to go ahead and rationalize that so we don't have an irrational denominator. So I have plus or minus 3 root 2 over 2. Okay, now I have to minus the 2 over to the other side. Negative 2 plus or minus 3 root 2 over 2. And if I wanted to combine that into one fraction, I could turn this negative 2 into a 4 over 2. Which means I could write this, I'm going to go to the left, as x equals negative 4 plus 3 root 2 all over 2, now that they have the same denominator. Negative 4 plus 3 root 2, and then I divide it by 2, I get 0.121 as one of the x-intercepts. And I'm doing plus or minus 3 root 2. So negative 4 minus 3 root 2 divided by 2 gives me negative 4.121. as the other x-intercept. Now, just to make sure that we can tell that that is what the parabola is, 2x squared plus 8x minus 1. I'm going to go over and graph this on Desmos. Y equals 2x squared plus 8x minus 1. So I can see my 1.121 x-intercept, comma 0, and my negative 4.121 x-intercept, comma 0, because we put in 0 for the y. So I've confirmed that my two x-intercepts here that I have are correct. Okay, they could be written as coordinate points if you like. You don't have to rewrite every single answer as coordinate points, but I just want you to understand that they do represent a full coordinate point that ends up on the x-axis. You could write it as the perfect exact value by writing it with the square root. But I don't expect you to write up for every problem. I just want you to understand that that is what the x-intercepts are. Okay, so in class, we did a couple more practice problems today. If you weren't there or haven't done them before, I would recommend you try them on your own and then come back and check them. You can always pause the video now and then come back to it. But I'm going to go through them now. So if you want to pause the video, do it now. Otherwise, just keep listening. So I'm going to do x squared minus 5x minus 3 equals 0. I'm going to move that trailing constant term over to the right side. Then next, according to our steps, after we move c over to the right, we factor out a if we have an a term. But we don't. Ours is just 1 on this one, so I'm not going to bother with factoring out a 1 because that wouldn't make any difference. So next, I add b over 2, so our b is this time negative, squared, to both sides. So I'm going to add 5 over 2 squared would be 25 over 4 to this side, and 25 over 4 to the right side because there's nothing outside of parentheses to distribute. Again, the beauty of this is the number that we're getting ready to need is right there in the parentheses. X minus 5 halves squared equals, well, 3 I'm going to write as 12 over 4, so I can add it to 25 over 4 and get 37 over 4. Now I am going to square root both sides now that I have the squared term isolated. So I have x minus 5 halves equals, well, plus or minus square root of 37, but the square root of 4 is just 2. So that's great. Now I'm going to add my 5 halves over to the other side. 5 over 2 plus or minus square root of 37 over 2, which means x equals 5 plus or minus square root of 37 over 2. Now, as decimal values, 5 plus the square root of 37 divided by 2 is approximately 5.54. I guess you could put 3 digits if you want 1. And 5 minus the square root of 37 divided by 2 is approximately negative 0.541. Let's check this on Desmos just to check. It's good to check it at first while you are, getting comfortable with what you are doing. X squared minus 5x. Turn this graph off. We don't need that. So you can see your 5.541 and your negative 0.541 for your two x-intercepts there, and verify those. One more, and then we will be done with the first half of this lesson. Okay, this one combines kind of the aspects of the previous two problems. The aspect of having like a fraction when you're completing the square, and the aspect of having a leading coefficient that you have to factor out. So this kind of is a combo in that regard. So let's go about solving it. All right, so 2x squared plus 7x equals -1. I'm going to move that to the other side. Going to take out my GCF of 2 out of those terms. So I have 2 times x squared plus 7/2 x equals -1. I'm going to add b over 2 squared. All right, well, let's think about that. If you are dividing a number by 2, isn't it the same as multiplying it by 1/2? So basically, whenever you need to multiply a fraction by 2, you can just double the denominator. So b over 2 would be 7/4 squared is what I'm going to add over there. So I am going to add 49 over 16. That's 7 squared over 4 squared. So technically, I haven't just added 49 over 16. I've added 2 times that. So on the right side, I have to add 2 times 49 over 16. See, this last term will never be negative because you're always squaring a number, whether what's in there is positive or negative. All right, let's start cleaning up then. 2 times x plus 7 over 4 squared equals, let's see, 2 over 16 is going to reduce to be an 8, so that's 49 over 8, which means I'm going to make this -8 over 8 so that I have common denominators. That's going to give me 41 over 8. So next I need to divide both sides by 2 in order to start isolating and solve. So those 2's cancel. That's not bad. X plus 7 over 4 squared equals, again, if I'm dividing a fraction by 2, I'm just going to double the denominator. So that's going to bring me back to 41 over 16. Now my next step is to use my square root property. I'm going to square root both sides. So that's going to give me x plus 7 over 4 equals plus or minus square root of 41. And then the square root of 16 is just 4. So that's nice. I subtract my 7 over 4 to the other side. And then combine my fraction. -7 plus or minus square root of 41 over 4. Let's get our decimal approximations off that, and I'll make my arrows look a little nicer. Okay. -7 plus the square root of 41 is approximately -0. Oh, and now I got to divide it by 4. -7 plus square root of 41 divided by 4, -0.149 approximately, and -7 minus the square root of 41 divided by 4 is approximately -3.351. 2x squared plus 7x plus 1. You can guess what I'm going to do now. Just going to go back and change this one to be the current one we are doing and turn it on. So I have my -3.35 and my -0.149. That kind of confirms those answers that we just got. So that is the end of the first half of the lesson on completing the square and vertex form. We've done completing the square. Join us for the next one where we will finish the notes and change things to vertex form by using completing the square.